Hi, everyone. I'm myself, Vishal Verma, and the theme of this masterclass basically is to kind of talk about, in brief, combating the application release delays by using the pen testing automation, right? So I'll start off with sharing my screen real quick. Just give me a second. I hope my screen is visible to everyone, right? So in this masterclass, we'll talk about how the automation in pen testing, right, or the pen testing automation starts to kind of accelerate the journey for releasing the applications, making it more secure, and then helping organizations to kind of scale through their applications towards production in a more secure manner, right? So briefly talking about what BreachLock is. BreachLock is one of the global leaders in providing pen testing as a service, right? BreachLock is one of the full stack service provider or a PTaaS player in the business, and which basically covers out the entirety of the landscape together, right from web application, networks, API, IoT device, mobile applications, and many more, right? And not just limiting ourselves into the pen testing space, but we also explore and I would say kind of venture out in the fields of red teaming and phishing capabilities as well. So, and BreachLock has been trusted partner for over 1,000 plus organizations globally and have conducted over 20K pen tests in the past since inception, right? And the basic demographic that we see, and BreachLock has serviced various industries that you can see via the pie chart, and majority of them are related to software and IT services, right? And that's where it directly kind of gets in line with the agenda and the theme of the security masterclass, how to kind of accelerate the growth and move along the application releases into production and making them more secure and robust rather than making them vulnerable, right? One more thing about BreachLock is basically rated as 4.5 in the Gartner peer insights and 4.8 star rating in the Gartner G2 reviews. So that's a brief introduction about BreachLock. Let's dive into and look at the problem statement first while talking about why do we need to kind of include pen testing automation? What does the value that it brings into the table for our customers, and what is the differentiator that BreachLock brings to the food chain entirety when we talk about the pen testing as a service space, right? So, yeah, let's look at the problem statement now, right? So the problem statement basically is how can we ensure the applications are properly configured? That's the majority of the CISOs that we talk about and we talk to, or the security professionals. They're the one single question that's basically just kind of spreads across the geographies, across the portfolios, across the designations within the organization, that how can we make our application secure and without slowing down innovation, because innovation is the need of the hour, and various and a lot of feature-rich applications are being released into production, but are they really secure? That's the question that they want to kind of get answered through the assessments that we do as pen testing as a service provider, right? So there are certain issues that comes along with the innovation and the accelerated growth journey, right? So innovation moves quickly to stay competitive, right? But this definitely adds a lot of complexity into the IT estate of the organization itself for a feature-rich application, right? So if you have a feature-rich application, it takes a lot of IT infrastructure, it takes a lot of business logics to be kind of built and baked in together, a lot of complex workflows to be designed. That also, on the other side of the coin, or the flip side of the coin, introduces a lot of security-related issues, security vulnerabilities, which kind of get overlooked during the development lifecycle if that's not baked in properly, and raises a lot of concerns for the CISOs before that goes into production. Is it really secure? Are we good to kind of go forward with the release or not, right? And I would say the more complex, the more vast the IT infrastructure is, the landscape is, the bigger the foothold is for any of the attacker to kind of come in and launch any kind of sophisticated attack into the environment. The second problem statement is DevOps basically are under pressure to achieve faster release cycles, right? That's one of the biggest concern that we foresee and we talk about in the industry as well, that is it really worth trading off security versus velocity into the release cycles that are being put forward, right? Agile is one of the examples wherein a lot of security features are being put into backlog just for getting the application stamped in for production. But is it really secure in that manner? That's the question that still remains kind of unanswered, to the point wherein we step in, do the pen testing, and then identify a lot of vulnerabilities or loopholes in between. The next one is kind of a very traditional phenomena or paradigm that we still see in a lot of organizations. It's kind of shifted already to an extent, but not to the point wherein we can definitely say that it's more like agile. People want to kind of fail fast and learn quickly, but it's more like a traditional approach wherein any application is being developed, tested, and then before it's brought into production, that there is a need for any pen testing company to kind of come in and do the pen test. But that approach basically adds a lot of issues because the security issues, the security vulnerabilities are uncovered during the end of the development life cycle, which basically adds a lot more cost in terms of time and effort to recover those vulnerabilities and rebuild and rebake security into the application. And the last one is basically traditional pen testing slows down the release cycles and hinders innovation, right? It basically kind of touches upon or briefly overlaps with the third point that we talked about. But any issues which are uncovered during the last phase of the release, right? Before it, I would say, or N-1 phase of the release cycle, that cost, I would say, kind of a huge amount of rework in terms of effort and money for any organization to go back and redo the exercise of building or fixing up those vulnerabilities, right? And that does not just relates down to the materiality of the risk that we identify or a pen testing company would be identifying, right? It basically boils down to any security issue which can be kind of correlated, collated, and then later on used for a very sophisticated means of attack. Even a low severity vulnerability can result into a high or a critical vulnerability when it is launched into production, depending on the volume of the data, the nature of the data, and the sensitivity of the data that is being put forward. So moving forward, pen testing throughout the SDLC lifecycle, right? So it's basically the term coined into a lot of IT industry, a lot of security, software industries as well. But what really it means in terms of the pen testing when we look at from the aspect of an adversary, right? How easy it is for someone to kind of step in and break in, rather than looking at, I would say, the entirety of the life cycle phase to kind of see through how it can be made more secure, right? So the primary phases of a SDLC life cycle basically revolves around 5 main components, right? Planning and design is one of the most important element because that's where we plan the application, how it would function, and then design the security architecture of it. If this phase is not done properly, not done appropriately, then in the entirety of the blockchain or entirety of the food chain that goes within the SDLC lifecycle is already kind of jeopardized or at stake of a security risk being manifested within the application itself. Then comes development, testing, deployment, and then maintenance, right? More like run and maintain mode. So we'll look into the individual segments of the SDLC lifecycle coming into play and talk about what continuous and automated pen testing or pen testing automation brings into the table for all of them to kind of step in and kind of collectively work together to make a very secure and a holistic application, right? So embedding pen testing throughout the SDLC lifecycle basically not just ensures, but also assures the organization and the C-suite and the executive management that security is baked in appropriately right from the foundational level. And even if there are security flaws or vulnerabilities identified, it would require minimal, or I would say kind of more like a fine tuning of the security settings to bring it to an optimum level to meet the benchmark of the security requirements within the application. So within an SDLC, the first phase basically, as I mentioned, right, planning and design, that is kind of a very important phase because that's where we conceptualize the application, the security requirements and everything, right? The primary contributions and the activities that come into play for the planning and design phase are basically finalizing the security requirements, talking about the designs as well. And that comes down to threat modeling, right? So it talks about identifying potential threat vectors based on the application architecture and design by using the known threat modeling schemes such as Stride and Red, but that depends on the organization which approach they want to pick. But they both relates back to identifying threat vectors associated with that application or that development lifecycle altogether. Then comes down the security architecture review, right? It basically assesses the design and the security flaws for known weaknesses. And then comes down the secure code reviews, just by reviewing the code snippet and just kind of looking at the known vulnerabilities in the known libraries can save a lot of time for an organization to kind of unplug a vulnerable component and then bring in a more secure one at a later point of time at the planning phase itself. The common vulnerabilities that we have seen resulting into design, or I would say improper design and planning phase, are inadequate authentication mechanisms, right? That basically relates down to weaker encryption algorithms, weaker authentication mechanisms being used, I would say weak password parameter strings, no improvisation or requirement of 2FAs being factored in, or even if they are factored in, they are not appropriately designed and implemented. Improper access controls, right? The roles are not tightly controlled. The RBAC is not defined appropriately to make sure the application is stringent and strong enough to enforce those segmentations across the roles to guarantee no exfiltration of data or no unauthorized access of the data to the or within the application. And then the data leakage risk, right? That basically revolves around, again, having an unauthorized access to the application or to the data set by any users or roles in any what capacity within the application that may relate or allow anyone to have access to a data set that they are not supposed to do so. So that's primarily around the planning and the design phase. Then we move along on to the development phase. That's where the actual coding starts to kind of take place, right? That's where the developers would start to kind of code into specific language and then break down the business requirements into more like WBS or work breakdown structures, create down sprints, epics, and start to kind of code through. That's where the requirement of static analysis, code reviews, and security unit testing come into play. So when we talk about static analysis, or basically called as STAT, which basically analyzes the secure code or analyzes the code for security vulnerabilities using automated tools, be it SonarQube or any other tool that comes into play. Then comes down the code reviews. It's more like a manual review of the security code or manual review of the code itself by an independent assessor or within the peer itself, right? That kind of uncovers a lot of manual or human errors that are baked in within the security or within the code itself while developing or following through the SDLC process. And then the security unit testing or the secure unit testing that would happen, and wherein the unit testing codes or unit testing scenarios are being tested for the application. And negative unit testing comes into play very heavily into this aspect because positive and negative unit testing, positive are more like towards the use case wherein the application is intended to behave in a fashion. Negative use cases or negative unit testings are basically done against the expected behavior just to make sure how well the exceptions are being handled by the application, how well the application handles any anomalous input which they are not expecting as part of the input from an external, I would say, individual or user. That's where the unit testing comes into play, or play a major role in the development lifecycle itself that would start to kind of identify and uncover a lot of vulnerabilities coming into play. Common vulnerabilities that we have seen that resulted during this development lifecycle or an improper development lifecycle or the injection attacks. That's the most common attack or type of attack that you would see against a web application that does not really follow through an SDLC lifecycle rigorously, right? And it's very common nowadays having SQL injections, cross-site scripting, and etc., right? Then insecure usage of APIs, right? That talks about having an access or an API built in that would, I would say, use or connect to multiple data points that it is not supposed to, right? For a faster development sprint, I'll just take an example. We have seen such cases in the past wherein the entirety of the data set is exposed to the API, but it was not necessarily needed. That basically resulted into data exfiltration, access to sensitive data set that an external user is not supposed to do so. User enumeration is, again, a very strong possibility comes in or originates from this kind of insecure API usage. Then comes down to the cryptographic weakness, right? Are we using any deprecated versions of encryption algorithms, any weaker means of encrypting the data set that is not necessarily needed, right? Or even for a faster data processing or data transaction in between encrypting and decrypting the data set between the database and the application, or vice versa from the client side or the server side, Are we compromising onto the cryptographic needs? Are we compromising on the encryption and the decryption capabilities of the data set itself, right? So all those things comes into play or uncovers or raises a security concern during the development lifecycle if they're not done appropriately. Moving along towards the testing element, right? That's where the real testing would start to kind of come into play. And that's the basically the game changer between the development and the deployment lifecycle, whether the application goes through or not. A majority of the traditional pen testing organizations and organizations come into play for this section to identify vulnerabilities in between, right? And that's where DAST, dynamic application security testing, dynamic analysis, manual pen testing, input validation testings come into play. So these are the three major categories that come into play. So we'll talk about DAST a bit, right? So in the previous segment, while during the development lifecycle, we talked about SAST. That's where the source code and the static analysis happened without the runtime analysis of the application itself. And during a dynamic application analysis, every negative scenario, every positive kind of fired through and see and observe the behavior of the application just to see how well the application handles those kind of exceptions. Then comes down manual testing. That's where a lot of penetration testing would happen, and to uncover vulnerabilities, to uncover sophisticated attack, business logic flaws, and many more capabilities come into play while doing the manual testing. Then comes down the input validation testing, right? So are we capturing any malicious input? Are we handling the exceptions or the errors properly? Not displaying any, I would say, kind of an object or a data set, or having insecure deserialization or an IDOR altogether coming into play for these kind of areas, right? And the common vulnerabilities that we have seen is definitely cross-site scripting, the possibility of using iframes to redirect a user to a malicious script sites. Those are not handled very well, right? So CSRF, cross-site request forgery, just to kind of intercept the request coming in from a user and then take them to a falsified or a malicious website altogether. Broken authentication, right? Even session management, if not baked in properly within the application by itself. We have seen cases wherein these sessions are not terminated properly. It's not sticky session, right? The moment you terminate the session, but reopens a browser within the same, I would say, kind of fragments of seconds or fragment of a time frame, it still allows you to kind of log in or users to stay logged in and then act on it. Then sensitive data exposure, right? If the data is not sanitized properly, not hidden properly, masked properly, the data is still available for the malicious insider or an external adversary altogether, which they are not intended or authorized to do so. That's the phase wherein a lot of pen testing and automation come into play. Then comes down the deployment phase, right? That's where the deployment comes in, and more like a post-implementation security review starts to kind of happen. Everything works well during the testing, and then comes down the deployment phase, and then the application starts to kind of break through or introduce new vulnerabilities coming into play, because the environments that are being set across for testing, development, and deployment are a bit different in nature in terms of security configurations, right? That's where we saw a lot of configurational reviews related issues, weaker security configurations, and the network testing basically revealed a lot of unnecessary ports being used, services which are available in the production environment, which are not necessarily being used, but they are still open. And that basically invites an attacker to start to kind of manipulate and fudge around the ports, fudge around the services, and then gain an access internal to the organization or to any other, I would say, kind of data set that they are not authorized to do so. Very common vulnerabilities, as I talked about, the weaker configurations, unnecessary ports, insufficient network security, that basically allows kind of a backdoor access to an internal network of an organization. So we have seen cases wherein an IT giant left a vulnerability or a backdoor open accidentally by launching in a new machine into the environment that which was exposed to the external world, and using the automated means of pen testing or automation in pen testing, we were even able to kind of get down an RCE. That's a critical vulnerability that was being injected within the environment, and we were able to kind of have a remote code execution within the IT environment of the organization itself. And the last phase basically is the maintenance phase, right? That's again one of the important phase to kind of keep the application up to date and secure, right? So that's where the patch testing, right? Deploying security patches regularly by deploying, testing the security vulnerabilities, look for new patches, look for new vulnerabilities, and keep the environment up to date becomes very important within the application infrastructure and the IT estate for an organization. And then recurring pen testing, right? So getting a pen testing done once would not just kind of suffice. It definitely ticks the box for the compliance requirement, but does that makes the application really, really secure is a question that a lot of clients and a lot of CISOs asks us. And everybody knows, right? The threat landscape evolves every single day, many folds, right? So that basically keeps the application vulnerable every single time. So getting a pen test done once definitely takes out the compliance requirement, but not necessarily takes out or saves you from any future attack that is coming in from, right? So that's where a recurring and a regular pen testing or a frequent pen testing is very much advised by any of the organization, any of the security professional that basically works in the environment, right? And again, coming down to the vulnerabilities that we have seen for improper maintenance or irregular pen testing coming into play, unpatched vulnerabilities, end of life softwares, end of life machines, right? Which does not really releases patches for security vulnerabilities as of date, which exposes the organization and the environment altogether for a big vulnerable attack and invites an attacker to kind of have an unnecessary access or an unauthorized access to their environment and then control the environment altogether by themselves. So that's primarily about the SDLC and then the pen testing throughout the SDLC lifecycle or the security requirements throughout the SDLC lifecycle. Moving forward, right? So just a case study wherein BreachLock worked as a partner with one of the leading consulting firm in the world, and they were in a very similar situation wherein they were having a big, huge backlog of applications to be released into production. As you can see, the scope was around 800 applications that included web applications and mobile, 30 API pen testing project, internal and external network, up to 400 IP addresses, right? So they had a huge voluminous backlog, which was sitting into their environment and waiting for them to kind of release to or move along, right? And that's where the automation in pen testing came into play. And BreachLock basically leveraged the automation in pen testing and help the client to kind of kickstart their pen testing project, not like a traditional pen testing projects, but I would say as an accelerator in between to make sure that we scheduled or we started off their pen testing project within the 24 hours or one business day of the scoping itself. And that basically that accelerated commencement and I would say initiation of the pen testing projects by leveraging the pen testing automation, which basically scaled our pen testers to kind of do more than what a traditional pen testing organization was able to deliver to them, eventually eliminated the backlogs within weeks. And then they consolidated all their pen testing projects or requirements into one single vendor that was BreachLock, right? The outcome of that engagement was a significant reduction in the risk exposure that the organization had, because when we pen tested 800 applications, there were a lot of applications which were vulnerable and which they were just kind of pushing through the borderlines to get it released. So that risk exposure was downgraded significantly. The overall backlog was reduced already. Then the time management for managing multiple vendors for that global consulting firm reduced drastically to one, basically. They earlier had 3 pen testing providers, which were basically running behind the schedule as they were following the traditional approach. We reduced the total cost of ownership of applications than managing the vulnerabilities and making the environment secure by 50%. And then it was more like a consistent and a robust process, tried and tested means of deploying and delivering the results in a more consistent manner. So with that, I'll just kind of move along to the next. Yeah, okay, just give me a second, sorry. Right, how automation basically accelerated the pen testing, right? So we'll briefly just kind of spend a bit more time here. And we identified, right, by leveraging automation, a lot of vulnerabilities, the low-hanging fruits basically, right, are automated in nature, wherein we can leverage, or we have leveraged BreachLock basically, leveraged the AI capabilities and have developed sophisticated logics, which in turn saves a lot of manual effort for validating a vulnerability which can be absolutely 100% automated by throwing out various logics, various scenarios that would kick in as and when, depending on the situation that comes in true. And that saved a lot of effort for us in the previous case study with one of the biggest consulting client, and we have accelerated and delivered the project within 50% of the time efficiency and the gain that the client had. Certified in-house pen testers, QA findings to ensure zero false positive, right? The more time we get and the time gain that we identified and obtained by leveraging the automation in pen testing is dedicated to make sure the quality of the pen test reports are not sacrificed with the shortened duration of the time frame that we are taking for delivering out the reports, right? So the automation comes into play to scale the pen tester, to scale a security researcher, not just to kind of augment a human-led pen tester or a human hacker altogether, because that's where a lot of intel remains. The automation basically produces and generates a lot of intel about the client environment, a lot of true positives, ensuring that any single possibility or a vulnerability that can manifest in an environment is being captured, is being factored through. And that time saving or the time advantage that we get by leveraging the automation in pen testing is being dedicated very specifically for the quality assurance of the report. And again, the results to ensure the utmost quality of the pen testing report quality with significant reduction and shortened time frame with a traditional pen testing basically helps us to deliver more within a shortened time frame with high quality output, or at par with any traditional organization, basically above and beyond that, right? And then pen testers spend more time in doing manual deep dive on a targeted asset, right? So as we leverage automation that scales up and saves a lot of time by identifying low-hanging fruits for the pen tester, the security researcher or pen tester can process the information which was produced by the automation and craft more sophisticated and creative attacks to identify exploits and vulnerabilities within the business logic itself. Or a lot of time is being spent through to understand how the business workflow works together, and then craft out a more stretched through scenario and a sophisticated attack that would impact directly or attack directly the business logic and the workflow by itself, rather than just very specifically spearheaded looking at one segment of the application and then identifying a vulnerability or try to uncover a vulnerability, which a lot of traditional pen testing organizations or pen testing approaches fail to do so because of either shortened amount of time or the effort that is being spent across in identifying low-hanging fruit, which basically kind of being identified by the automation itself within the BreachLock category, right? So with that, I'll just quickly take you guys through with the application and how that vulnerabilities and the automation engine starts to kind of work through. So I'll just quickly shift through the screens for a quick glance. Just give me a second. I hope my screen is visible. So this is basically the demo portal, and this is how the vulnerabilities and the automation starts to kind of come into play. So if you look through the capabilities or the information that are being generated by the automation engine, right? So this can be, this basically depicts an automated vulnerability. The automation engine generated this vulnerability. It is a true positive validated by the security researcher. So if I just take a scale of 10 vulnerabilities here, 30% of the findings or 30% of the scale-up efficiency is being brought in directly via the automation engine itself or the pen testing automation itself. And that the same engine is being leveraged through towards the automated scanning for the dynamic application scanning activities and even for the SAST capabilities as well for the scale-up efficiency that is being brought in towards the client. So I'll just take a pause here. That's quite a lot of intel that I've kind of thrown out. And any questions, I would say I'll just kind of take a pause here, but happy to answer any questions if there
are. Yeah, Vishal, I think there are 2 questions in the Q&A tab. You can check it.
Okay, let me just quickly go into the Q&A tab. Okay, apart from agile methodology, what all SDLC methodology can be adopted to minimize security risk? Okay, that's Frehen, if I'm not mistaken. Okay, I'll consider that right. So I would say any of the security or any of the SDLC methodology that is being adopted, it has to be baked in with security coming into play, right? So SDLC can be one of the framework, but that also depends on the business objective. What is the application trying to do, right? But if you look through OWASP top 10, that's the industry frameworks that are basically talks about how an application should work. If they are being factored in properly, NIST, the cybersecurity framework, the latest version that's 2.0 in the draft state currently, but would be coming into play for, coming into play for the October itself, for the feedbacks, and then eventually being rolled out in the earlier January 2024. That would come into play and that would make the application more secure, be it any waterfall model or the agile model, any of them. If the security checks are baked in between and the security assessments are done appropriately during the life cycle of the phases, that would definitely make the application more secure and robust altogether. The second question I have is from an anonymous attendee. Is there a right way to automate pen testing? How should we prioritize the goal for automation here? Okay, so when we talk about automation in pen testing, right? So it cannot augment, having said that, right? So automation is a good element to have, but having just the automation piece would raise a lot of false positive. And it's more like kind of a journey by itself to kind of make it so mature and robust to a point wherein it would just kind of start to give you kind of zero touch finding or absolute true positive. And that's where I would say kind of BreachLock matured over 5 years into this space. We started off as one of the only player into the pen testing as a service business. And now then along with us, there are a few more big organizations that kind of joined in. So if we keep on fine tuning, we keep on innovating, and we keep on adding more scenarios to automate to that automation engine by itself, then it would start to kind of make the results more towards the true positive side than towards the false positive. But having said that, automation can only be used to kind of scale up a human hacker, but it would not just kind of augment the necessity of having a human element or a human security researcher sitting behind that automation and making sure that results are true positive. It's more like kind of an ongoing journey. And it would always remain like an ongoing journey unless we achieve like every single possible scenario is being touched upon, which is highly unlikely. We still struggle to kind of achieve that level of maturity. We have reached a certain level of maturity, but we are still kind of innovating and making sure our automation works at par with the requirement that we currently have. And how should we prioritize? The goal for the automation here is basically, again, coming down to the objective of the exercise itself, right? The pen testing or the organization by itself. What is the vision that they're kind of coming in, just to make sure the development, the innovations, and the efforts are being spent across during that direction or within that direction itself, just to make sure you are addressing the business objective first with using the automation in the pen testing here. So I hope that answered your question. Aarti, I do not see any other question apart from that. Is there anything else for me?
No, I think that's what we've had. I'm just seeing. Yeah, I think
Okay.
now I know to move away from fully automated pen testing. How do I know which teams to use? Yeah, I think you can read that one.
Yeah, definitely I can read that. All right. So it says now that I know to move away from fully automated pen testing, how do I know which teams to use, right? So okay, so it's again with alignment with the business requirements altogether, right? So it's not just fully automated pen testing, right? Because if a tool can provide you the output or the results that a human hacker or a human researcher would be able to kind of provide, there are tools, but it's more like, again, kind of automated in nature, which produces a lot of false positive, right? Which creates a lot of overhead for the client or the person who is kind of receiving and absorbing the results out of it to go back, validate every single thing. Wherein if you augment that with a human hacker altogether, it would give you more fruitful results. That's the first part of the question. I hear so much about the outsourced testing and the community of testers, and that seems like an area that could introduce more risks. No, how do I make the right decision? Absolutely yes, right? So vetting through the security researchers, right, or identifying an appropriate vendor would definitely be one of the paramount requirement, because you're talking about vulnerabilities, you're talking about weaknesses within an environment. And if you just kind of expose that information or intel, which is very sensitive in nature to an organization, to a person who is not vetted appropriately, then it definitely kind of exposes the organization to a greater risk than to have a weaker, or let's say kind of a vulnerable application by itself. So how do you make the right decision is by vetting the organization, doing a security assessment, taking a third-party assessor by itself to vet the organization, do a security validation, look for the credentials the organization have in terms of certifications, what kind of employees do they have, what kind of employee hiring mechanisms or hiring techniques that they have. Do they outsource? Do they crowdsource? Do they have a full-time pen testers or full-time security researchers within the organization? All those kind of questions would help you make the right decision. So I'll just briefly talk about BreachLock, and that's where BreachLock kind of plays a, I would say, or aces the other vendors. BreachLock do not outsource any of this intel to a third party or to a part-timer security or a freelancing security researcher altogether. BreachLock always have a full-time employee, full-time security researcher that basically goes through a rigor of background validations, background checks. And being a CREST accredited organization, there are, I would say, kind of a laundry list of checks that we have to kind of abide by as part of the BCG, or the background clearance check, or a background certification check for an employee before they get onboarded and get access to such kind of a critical intel or very sensitive intel from our clients or for our clients. So all those things coming into play collectively together would help you identify the right organization to assess the security posture for you. I hope that answered the question.